Now let us solve this. Examine for continuity and differentiability for the given function f of x. So left hand limit should be equal to right hand limit should be equal to f of 0 here. F of 0. So left hand limit at x is equal to 0. The left hand limit will be limit x approaches 0 minus limit x approaches 0 minus x into sine 1 by x. How do you solve from here? What do you get? X is equal to 0 minus h. X is equal to 0 minus h. So limit h approaches 0, 0 minus h into sine minus 1 by h. Sine of minus theta minus sine theta. So we will get limit h approaches 0, h into sine 1 by h. Minus into minus positive. Right? Now let us split limit h approaches 0, h into limit h approaches 0, sine 1 by h. Just now we saw this value is bounded between minus 1 and plus 1. So we are going to get limit h approaches 0, h into minus 1 into plus, minus 1 to plus. So once you apply this value over here, what do you get? 0 into any value between minus 1 and plus 1. Answer is going to be 0. Yes? Answer is going to be 0. So it would be the same for right hand limit as well. Instead of 0 minus h, you will be substituting 0 plus h. And it remains the same. Again, you get 0 only. Yes? Now, if you directly substitute also 0 into any value, minus 1 to plus 1, again 0. So now let us look for differentiability. We look for differentiability. So left hand derivative. Let's take left hand derivative. What is left hand derivative? Or let's talk about right hand derivative first, so that you won't get confusion. Right hand derivative, let's take. So f dash of 0. F dash of 0. Limit h approaches 0. F of 0 plus h minus f of 0 divided by h. Yes or no? That is the definition, right? Yes. Now substitute limit h approaches 0. In place of x, you are going to replace 0 plus h. So h into sine 1 by h minus, anyway, this part is going to be 0. 0 into anything is 0. 0 into anything is 0. Divided by h. Yes. Till here, any calculation for anyone? Now cancel. Now tell me what is the value for this. What is the value of this? Can you say a particular value? So you will conclude does not exist. Therefore, it is not differentiable at x is equal to 0. Is that clear? Understood? Okay. Now let us see this part. Now this is differentiable. Now this becomes differentiable. Why? Because they want to smooth it. Okay. Right hand derivative should be equal to left hand derivative. Okay. So let's take right hand derivative at x is equal to 0. So f dash of 0 is equal to limit h approaches 0, f of 0 plus h minus f of 0 divided by h. So limit h approaches 0, h square into sine 1 by h minus 0 divided by h. Correct? Yes or no? Now you have learned this one in continuity just now. Limit h approaches 0, h into sine 1 by h. What is the answer? What is the answer for this? You're going to get 0. 0 into a bounded value. See, this is going to be 0 and this is going to be a bounded value between 1 and minus 1. 0 into something is going to be 0. Is that clear? Now work out the same for left hand derivative. So f dash of 0, limit h approaches 0, f of 0 minus h divided by h. So limit h approaches 0 minus h square into sine 1 by h, which is minus, divided by h. So you're going to get limit h approaches 0, h into sine 1 by h. That is again 0. Yes. So your left hand derivative is equivalent to right hand derivative. Therefore, it is differentiable at x is equal to 0.